So we'll start this exercise as well. Every session we'll do at least a planning experiment question, as it's a very important topic regarding paper six. A 6 mark question is there, sometimes 7 marks. So the first question we'll solve from this exercise. The first question is about calcium burns in air to form calcium oxide. The reaction is vigorous, and some of the calcium oxide can be lost as a smoke. Plan an investigation to determine the maximum mass of oxygen that combines to form calcium oxide when 2 grams of a calcium granules are burned in air. You are provided with a common lab apparatus and calcium granules. So first I'll draw how it can be done, and then I will mention the points. So first what we will do, whenever, like example, we want to burn a metal and form metal oxide, and we want to prevent it from it loss to the surrounding, we use a deep container, and what we call that deep container, we call that as a crucible. So what we do for this one, we use a crucible, and the crucible with a lid. So in the crucible, what we'll do, we'll take granules of calcium, 2 grams calcium granules are there. We know it's 2 grams, but what we'll do, we'll place this crucible with the lid and the calcium on the balance to know what mass is there. Like what is the mass of this whole apparatus. Then what we will do, using a Bunsen, like on a tripod stand, we'll place this crucible and we have under this, we have a Bunsen burner. The burner is there at the bottom and we burn. Because like calcium is reacting with oxygen, we want to form calcium oxide. And time to time, we will open the lid. Why we open the lid? So that every time there's a fresh supply of oxygen. Like otherwise, what might happen, that amount of oxygen, if it is limited, then the reaction may not be complete. Some of the calcium still remain as a calcium instead of turning into calcium oxide. So time to time, most of the time during experiment, we'll keep the lid closed, but time to time we'll open the lid so that fresh oxygen or fresh air can enter this crucible and it can react with calcium to form calcium oxide. And then what we will do, we will reweight. Like we'll measure the weight again. Like first we measure the mass of a crucible, lid and calcium. Then we place it like above the Bunsen burner and heat it and open the lid time to time. And then what we'll do, we'll reweight. But till what point we will reweight? Till what? Until the mass does not change. Because once the mass is not changing, we will identify that all of the calcium has turned into calcium oxide. Example, in the beginning of experiment, say the total mass was 2.3, the content. Then when we burned first time, like when we heated for some time, and then we measure the mass, it was 2.31. Then we again heat, it become 2.33. Then we again heat and reweight, it is 2.33. So until the mass is not changing, we are sure that all of the calcium has turned into calcium oxide. So then how I will know what, like, because the question is, we want to work out, like determine the maximum mass of oxygen. So how I will know the mass of oxygen which is reacted with calcium? So the original mass and the final mass will take a difference between them. Like the final mass minus the original mass will give us how much oxygen has reacted. So that's how we plan this experiment. Is it clear till this point? Any doubt in this? So first, what is the first point? for this planning experiment, because we want to find how much oxygen has reacted with calcium. So the first point, what we did, we measure, and always mention the apparatus you are using for your experiment, always mention their names. So we will measure the mass of crucible, lead, and calcium. By what we will measure the mass? By using a balance. And say this you're saying as M1. You can write the any variables you can mention, M1, M2, according to the value. First, we measure the mass of a crucible, lead and calcium by balance, and we call that as M1. Then what we do? We heat the crucible by the help of Bunsen burner, and open the lid time to time for fresh supply of air, or you can say oxygen. Calcium oxide will escape. No, because it's like we're not keeping the lid open. It's like open then close instantly, just to make sure that we have enough of oxygen available to react with calcium. It's not like we leave it, because if we leave this like remove the lid, then what might happen? Calcium turn into calcium oxide and it would be lost. So we don't want the calcium oxide to be lost. That's why lid will always be there, but only for a short interval we open. Then what we will do? We will measure the mass again. Or you can also mention allow it to cool down and then measure the mass again. Or reweigh until, and then repeat the procedure until no more, or no change in mass, or until a constant mass. So allow crucible to cool and measure the mass again and repeat the procedure until we have a constant mass. Then how we will know what is the mass of oxygen? So, and that constant mass, what we call, when we have a constant mass, we call M2. So the mass of oxygen reacted is equals to M2 minus M1. Is it clear, this one? M1 means the mass, the first mass we called M1, like we were having a crucible with a lid and there's a calcium inside. It can be any number, because you're not supposed to write the number, you're writing the variable, it can be any number. And you place it on the balance. When you place it on the balance, you call this first mass as M1. Then what you did, you heat using a Bunsen burner, you heat this and open the lid time to time so that fresh supply of oxygen is there. And you will repeat the procedure until the mass does not change. And when the mass does not change, so new mass, it will be higher than the first one. So the new mass will be M2. How we know what is the mass of oxygen reacted? The final mass minus the initial mass will give us the mass of oxygen reacted. Is it clear, this one? Anyone having a doubt or a question till this point? So I want everyone to answer this question and send your answers now.